Now we are going to start with the detailed study of the first type of the crystalline solid, that is the molecular solid, right. See, when we talk about molecular solid, it is clear that it is formed of molecules. That means the constituent particles which forms the molecular solid is obviously molecules, right. And you know that these molecular solids, the general characteristics which are possessed by this molecular solid is that they are generally soft when we touch them. Right, when we touch them, they give the feeling of softness because they are soft actually. And if we talk about their conductivity, they are mostly insulators, or you can say they have very low conductivity. The reason being, you know that for a substance to be a conductor, it should possess free electrons. So somehow we will see in its types that there are no free mobile electrons that can flow or that can make it a good conductor, right. So it is an insulator, or you can say it has low conductivity, right. And even when we talk about, because it is soft, so even we talk about its melting point, so it has low melting point. It has low melting point. But this molecular solid, as depending upon the type of force or type of conductivity or nature of the molecular solid, on the basis of nature of the molecular solid, I must say, it is being categorized into three types, further three types. One is the polar molecular solid, other is the non-polar molecular solid, and third is the hydrogen bonded molecular solid. So these three categories are the subcategories of the molecular solid. These three are formed of molecules and they are generally soft, because these are the characteristics which are possessed by the molecular solid, as these are forming the types of molecular solids. So that means these three are generally soft, they have low thermal conductivity, and even their melting point is low. Now we are going to study them in detail. I have few examples for you which we are going to see. Suppose first we are doing with non-polar molecular solid. As the name suggests, you know that non-polar means there are no such the poles present, right. There is no partial negative or no partial positive charge. The reason is that this molecule must be possessing the atoms which are of same electronegativity. See, so out of these three, you know that this is the example I am talking about. Right. So in this, there is a bond, triple bond between N and N, right. So that means this, because they are both are nitrogens, so that means their both electronegativity is same because their size is totally same, right. So when their size is same, their electronegativity is same, so that means that shared pair is going to stay in the mid of them, right. And as a result, there won't be any partial negative charge and there won't be any partial positive charge. That is why you call this N2 as non-polar molecule, right. And it is categorized into a non-polar molecular solid, right. And now if we talk about its properties, like if I am writing here, suppose I am writing the properties of non-polar molecular solid. So what conclusion I can make by just looking at the bond. So again, it is soft in nature, melting point is comparatively low, and moreover the force is not so strong, because the force is something you can say somehow strong when there are charges present, right. So because it is a neutral molecule, they have the equal attraction for the shared pair, so that means compared to other you can say that it has a weak force, right. So weak force is there, and even we talk about conductivity, so it has very low electrical conductivity. So that is, it is soft, melting point is low, obviously a weak force and low electric conductivity. And if we talk about the state in which it exists, so they are mostly liquids and they are mostly, it is appearing like cross, right. So they are mainly liquids, or you can say they mainly exist as gases. This is the non-polar molecular solid. As you know, N2 is a gas at room temperature. So this is what I told you, that mostly non-polar molecular solid exist as liquids or gases at room temperature. Now second we are taking up is the polar molecular solid, right. As the name suggests that it is a molecular solid which is polar in nature, right. What do you mean by polar? So that means there will be a difference in the electronegativity, right. We did in the previous topic. There is a difference in the electronegativity, that is why the shared pair is more towards one atom which is electronegative, and the one atom is actually deprived of that, right. So the one which has the more electron facing toward itself, it will acquire a partial negative charge. As you can see here, it is a polar molecule, right, and the one which is deprived is having a partial positive charge. This is what you can see here. in this molecule also, right. So that means this is like what kind of force they will possess. Obviously they're going to possess the dipole force, dipole wonderful force. So this is however more attractive force if we compare it with the non-polar one, right. So if we talk about the polar molecular solid, so that means they are going to be soft but harder if we compare with them, right, because they have a strong force, right, and even we can say their melting point is low in general, but still their melting point is going to be more if we compare it with non-polar molecular solid. You know the reason is that because the force between the polar molecule, that is between the dipole, is something strong in nature. So right, so it is, the melting point is generally low, but you can say if we compare it with non-polar, it is going to be high. And if we talk about conductivity, even the conductivity is low, because in this also there is hardly a free mobile electron which can move or which can be constituent of electricity, right. So again it has the low electric conductivity. And when we talk about the state in which they exist, so they mainly exist as gas. They mainly exist as gas. Suppose if I take an example of HCl, so you know that HCl exists